So the other ethics have very little front end.
Okay, so can you all see my screen?
Yes.
Okay. So as you can see, this paper is called Levels of AGI for Operationalizing Progress on the Path to AGI. So this paper is kind of inspired by the fact that, well, one, there's been a lot of discussion recently about LLMs and whether they've achieved AGI, but also just about like the need for this discussion to happen, especially in relation to like risks that these things pose, in order to come up with like a framework for development and regulation. That's really, yeah, that's why this paper is really focused on like how can we create a common language around artificial general intelligence such that we can foster like a productive discussion on understanding it and evaluating it and evaluating its risks and regulating it. I had a lot, but one thing I like about this paper is like all the examples that it provides. But before I go into examples of cool things that it provides, I think that I will go over it in terms of like the main points that it talks about. And then I'm going to probably go through it again, picking out things that I thought were interesting or cool. But how should I do this? Yeah, I guess that's, yeah, I'll go through the main points. I'm a little bit, should I go through case studies? Yeah, I'll go through case studies. Okay, so this paper is broken down into, I think, 6 sections. The first section is like this one over here about defining AGI. So it gives different case studies on how people have defined artificial general intelligence. The second one is actually about like, how do we, wait, it's over here. Sorry, I'm gonna zoom out a little bit. Yeah, the second one is about defining AGI. So it's like taking some of the lessons learned from these definitions, and then like, how should we actually look at it? Like, what should be the considerations that we should consider? Then they talk about like, what are the levels of AGI? So like, how do we evaluate what level of intelligence a machine has achieved? And then finally, well, there's one section about testing AGI, but then the final one that is about like assessing risk with respect to artificial general intelligence. So I'm going to go through each of these sections broadly and then specifically, so that we get some like repetition that allows us to like, retain these concepts a little bit more. So the first one about, let's look at the first one about defining artificial general intelligence in the case studies. So again, we'll go through these in more detail, but I'm going to go through them quickly. So the first case study is an example of, and probably the first example of us trying to define artificial general intelligence, is the Turing test, which is where you ask a human to interactively distinguish whether text is produced by another human or by a machine. So that's one way of evaluating intelligence. Another one is like this idea that artificial intelligence possesses this thing called strong AI, and it's basically saying like, we've achieved AGI when the machine that is exhibiting the intelligence can understand and like have other cognitive states, which is basically saying like it has consciousness. We'll go into a little bit more detail there. So that's an interesting one. The third one is human level. I skipped one. Oh, wait, analogies to the human brain. Yeah, another one that they talk about is just like that the machine works like the human brain, but I think they really say that one doesn't make sense, and we'll talk about why later. Then there's the fourth case study is on human level performance on cognitive tasks. So like problem solving ability that's similar to humans. The fifth idea of how to evaluate, so that's human level performance on cognitive tasks. So that's another way. Case 5 is the ability to learn tasks. So like to learn how to do new things. The sixth one, which I think is quite interesting, is like economically valuable work. So the assessment of AGI is like how much that work that like we are willing to pay it to do, or we would pay a person to do, can it accomplish itself? And this idea of evaluating intelligence based on economic work comes up a lot in this paper, so I think it's quite a good one. And then the last one, or not the last one, the seventh one is this idea of flexible and general work, and they call it the coffee test. But basically, it says like you come up with a set of benchmarks for a model that, like, if it can if it can perform these benchmarks correctly, then it will it's achieved AGI. And the benchmarks that are suggested by one person are understanding a movie, understanding a novel, cooking in an arbitrary kitchen, writing a bug-free 10,000-line program, and converting natural language mathematical proofs into symbolic form. So that's just a set of, but you can see like these are very high-level tasks that the system will be able to accomplish. And then the eighth example is artificial capable intelligence. And that one is the basic idea there is like, again, making money. And one of the proposed ones is that you give the system $100,000 and it, in a couple months, it makes it $1 million, which I was like, wow, I wonder if that's even possible in certain economic climates. But anyway, again, you see this idea of being able to make money with it as like the way of evaluating performance. And then there's a paper that came out by these two authors recently where they argue that LLMs have already achieved artificial general intelligence. So that's another example. Just that we already can see it in state-of-the-art LLMs. So you can see there's like a lot of different ways that people have proposed to evaluate performance. And then as like a reflection on these, this paper proposes 6 principles for evaluating performance. One is focusing on capabilities, not processes. So this one I think is really important because the idea is that you shouldn't focus on how something is accomplished and instead focus on whether it's able to accomplish the task. And I think this is important because we have, in the past, we've had so many biases on how a model should accomplish something to show that it's intelligent that like we're basically infusing bias into how we think should be performed. Whereas if you focus on capabilities instead of process, then you avoid this bias on like process that we seem to have. Focus on generality and performance. So I think that one thing that we've focused on a lot with LLMs is that they can perform a broad range of tasks. But we've kind of ignored at what level of skill they can perform those tasks. And so this is arguing, so we want it to be able to perform at a very high level on a specific task, but also perform well on a number of tasks. Focuses on cognitive and metacognitive tasks, but not physical tasks. We'll get back to a definition of what metacognition is when we come back here. But just so this is basically saying focus on like thinking tasks instead of tasks where you have to actually accomplish something physical. Focus on potential and not deployment. This one I think is really, this one I go back and forth about what, I can see why they're suggesting this, but I also think like, can we really measure performance through potential and not deployment? So here they're saying like, we shouldn't deploy systems to figure out whether they work. We should find tests that measure them potentially, which makes sense because you wouldn't want to like measure the performance of a model that like diagnoses a patient in practice. You'd probably want to measure it by its potential to do so instead of like deploying it in the real world. So that's another concept. And then there's focus on ecological validity, which means, this basically means focus on tasks that we actually perform in real life that make sense in terms of what people do, instead of tasks that don't really make sense. Like, for example, measuring an LLM's perplexity score that is not an ecologically valid task, because we don't care about perplexity when we're talking to each other. We care about like semantics and the syntax is understandable and stuff like that. Focus on path and focus on. Focus. Okay, so I guess what they're saying here for the last one is focus on a path to AGI, not a single endpoint, is this idea that when we're thinking about measuring intelligence, we should actually think about it in terms of like developing super intelligence instead of like a specific goal. So like we should think of it as this progression as we're defining intelligence, instead of thinking of it as like there's some end goal that we're trying to achieve, and these benchmarks should be achieved for, like, all benchmarks should be with respect to a specific end goal. Okay, there's two more concepts that I want to introduce before we go into detail about different parts. So this is talking about like how to think about artificial general intelligence. And here they define in section 4 levels of artificial general intelligence. And they have two different specific criteria that they use to measure intelligence. One is narrow performance, or like narrow AI, and one is general AI. So narrow AI is the ability to accomplish a specific task, and it's like how well can you accomplish that specific task, and there's different levels. So there's no AI, emerging, which is like kind of good, competent, which is like better than 50 percentile, expert of people, which is better than 90th percentile, virtuoso, 99th percentile, and superhuman, better than everyone. And then general. So narrow is like being able to accomplish a specific task really well. And then general is the ability to accomplish a variety of tasks quite well. And so they argue that we need to think about models in terms of both, because like we have models that can accomplish tasks at a superhuman level, but they can only accomplish a specific task. And then we have other ones that can accomplish a broad range of tasks, but not very well. So thinking about, they argue that's how we should think about artificial general intelligence, in terms of this like spectrum, which has two dimensions. And then finally, I'll just introduce risk. So for analyzing risk, the key concept that they talk about for thinking about risk in terms of artificial general intelligence is they argue we need to think about it in terms of like the level of deployment, or the way that we deploy it. So which they call autonomy levels. Everything's in terms of interacting with humans. So no AI is when a human does everything. AI as a tool is when we're like using AI, but we're mainly the ones guiding the process and the decision making. AI as a consultant is when you would use an AI to like provide, like help make decisions in a more substantive way. So maybe like they would tell you how large a beam should be when you're building a building. AI is a collaborator. So this would be, it can be an instructor. It can take on like a full part of the work where it's making full on decisions about what's going on. AI is an expert, where we would kind of trust it blindly. And then AI is an agent, where we let the model, the AI do everything. So you can see it's saying like, think of risks in terms of how the model will interact with the world. And then also they argue that different levels of AI allow for different levels of this type of interaction. So yeah, that was like a whistle-stop tour through the paper, but that's just to foster like talking about these things in more depth, because we've gone through all the big concepts. Okay, so let's go through it slower. and each part. So let's first talk about different case studies for artificial general intelligence. First, let's talk about the Turing test again, which is ask a human to interactively distinguish whether text is produced by another human or by a machine. So one cool thing or interesting thing about this test, which has been pointed out, is that in practice, the test often highlights the ease of fooling people as opposed to the intelligence of the machine. And I actually think that this concept of like seeing machines perform at like a high level and how it fools people into thinking they're intelligent is something we see all the time. So I think the Turing test is actually a good example of how not to measure intelligence, because it's really not objective. It's based on like a human and a human's idea of what's intelligent, as opposed to something that's like a little bit more a specific human's idea of intelligence. And one thing that they say here is that I highlighted is like, we agree with Turing that whether a machine can think, or while interesting philosophically and scientific, why an interesting philosophical and scientific question seems orthogonal to the question of what the machine can do. And so even Turing was like, we need to measure performance in terms of what a machine can do, not how it does it. The second one, again, is this idea of whether a artificial intelligence can understand and have other cognitive states. So this is about like whether we've achieved artificial general intelligence when a machine has consciousness. I actually think this one is a really out there definition of intelligence, because it doesn't talk at all about like whether a machine actually can do anything. It's just about whether it's conscious, because maybe you could argue that consciousness is a precursor for intelligence. But yeah, I thought that was an interesting way of thinking about intelligence, is that the ability to, like, is consciousness the highest form of intelligence? I don't know. There's a question.
Oh, that's just from me, Peter. I was just wondering, you covered this. Does it define consciousness?
No, in fact, they say there's no scientific consensus on methods for determining whether machines possess strong AI attributes such as consciousness. And I've looked very quickly, not now, but in the past, like at the literature on consciousness. And I think we still have no idea what causes consciousness from a scientific point of view.
Yeah, that's one of the interesting parts. Yeah. I think Doreen also.
Yeah, go ahead.
So I've been following a guy called Joshua Buck recently on YouTube, and he has quite a few videos where he talks about consciousness and how it should and shouldn't be defined. So if people are interested, check out Joshua Buck.
Okay, could you post it in the chat just so we can know the spelling of the name?
Yeah.
Thanks. And then, so the third case study is analogies to the human brain, and that like the idea that if an AI system works like the human brain, then or like better than the human brain, then it has achieved human intelligence. This is like an incredibly process-based way of evaluating intelligence, also human-centric, because it's saying that it has to work like the human brain. But they even point out, which I highlighted here, while neural network architectures underlying modern ML systems are loosely inspired by the human brain, the success of transformer-based architectures, whose performance is not reliant on human-like learning, suggests that strict brain-based processes and benchmarks are not inherently necessary for AGI. So this is an example where like anthropomorphic or like attributing human performance to intelligence just doesn't really seem like the right way to go. Yeah. I think there's another hand up. Or,
yeah.
I was just going to say, you know, that statement there where they mentioned, like, if the AI works better than the human brain, but like if the AI is just, you know, a text or a voice type of AI, then it's obviously not like the human brain, because the human brain does more than just process information. You know, it's like mobility and different things of body parts. So that sort of phrase in itself is, you know, illogical.
Yeah, actually, that's a really good segue onto the point that I thought was really interesting. On the next one is this case study. The case study 4 is like human level performance on cognitive tasks. So this would be tasks that don't require any kind of physical interaction. And what's interesting is that it brings up this concept of embodiment, which is there's a good amount of philosophy around the idea that part of the reason why we developed intelligence, or how we developed intelligence, is because we have a body and we interact in the world through this body. And so there's some people who think, I think I've even seen like Jan LeCun say that he thinks that embodiment is one of the important ways that like you learn general intelligence that machine learning doesn't have right now. But yeah, that's a really good point, that a lot of what the human brain does actually has to relates to interacting through the world through perception and through non-conscious thought and how it regulates the body. But I thought I just wanted to bring up this concept of embodiment because I think it's a really interesting question of like whether that's required for intelligence or not. Over here, they're saying no, and I can see why that's true. But they're basically, yeah, there's that. Case study 5 is ability to learn tasks. This is definitely, I think, makes a lot of sense that if like an artificial general intelligence can't learn to do something new, then it's really not that intelligent, because I don't think it's possible like to create an omniscient machine that can accomplish every task. It probably has to learn over time to accomplish new tasks. I bet you could show that mathematically too. Like the size of the machine would be larger than the universe or something like that. But before I answer that question, or in this case study, they introduced the idea of metacognitive tasks, which are tasks where you like question your own thinking or learning. And I think that personally, I think that's kind of like one of the up and coming fields of machine learning now, because I think we've been able to do a lot of cognitive tasks, but metacognitive tasks is really open. Yeah. Was there a hand raised or no?
No, I don't think so.
Okay, cool. Okay, and the next case study is about economically valuable work, and it says over here, like OpenAI's charter defines AGI as highly autonomous systems that outperform humans at most economically valuable work. And so this one really talks about how we should measure, not that the paper does, but like that we should measure intelligence based on economic value. But then they even point out that there's a lot of like intelligence that people exhibit, like artistic creativity and emotional intelligence, that can't really be directly connected to economic value, and probably that's why we shouldn't use economic value. Like I think that there's like the very famous example of Steve Jobs taking a calligraphy class, and then that like really helped him design like a font or something that became incredibly popular and made Apple computers really valuable. So like if we just cared about economic value, calligraphy probably wouldn't be something we'd want our machines to be good at, but it does have a downstream impact. So maybe economic value isn't the best way. I really like this case study 7, where they call it flexible in general, the coffee tests, because of this list of tasks, which I told you before. Like these are the tasks that they think you should use to evaluate a model, which are like understanding a movie, understanding a novel, cooking in an arbitrary kitchen, writing a 10,000 line program, and converting natural language mathematical proofs into symbolic form. So the cooking in an arbitrary kitchen highlights the idea that embodiment is a part of intelligence in this test, not in general, but just like in the test that's being proposed here. And I was wondering if anyone had any other like tasks that they would add on here that they could possibly think of.
I always
Or-
think of animals, right? So animals is always a question how intelligent are specific animals, and one of the best tests people figure out to whether an animal is conscious is having them recognize themselves in the mirror. Essentially, that combines the embodiment, right? So you need to have the body in order to have your physical representation of yourself. And then I think they do it like on dolphins or so, where they put like a red dot somewhere where there shouldn't be, and if they see whether the animal tries to get rid of it or so, that is a sign of awareness. And that all means you need some sort of robotic interface, otherwise it's would be hard to discuss.
Yeah.
I was saying that we have achieved intelligence when everybody sort of agrees it happened by whatever their measure is, but it's the same as humans, right? How can we be sure that every human is intelligent? Well, we sort of got so used to the idea that we assume it is the case.
Yeah, true. I actually, one thing I was thinking the whole time that I read this paper is that like that human intelligence is so complex and also very like the difference in mathematical skills between one person and another, but also like the difference because like, you know, being a very skilled craftsman might not be like a logical intelligence, but it is a form of intelligence, which is also very like, I don't know, very impressive and useful. Like just there's so many types of intelligence, so it's really hard to even define it. Case study 8,
I was just going to
artificial
say,
capable. Yeah.
I was just going to say about the list of tasks that you just highlighted, they also all have a unspecified element to them. So I don't know how well, you know, you as the examiner wants me to be able to, or the agent to be able to do those. And so I think that's actually a key point too.
Yeah, that's a good point, that there's some level of ambiguity that you have to be able to deal with. The second to last case study, but the last one I'll go over is, we talked about it before, artificial capable intelligence. And the test was like, give $100,000 worth of capital and task with turning it into $1 million over a period of several months. I don't even know if that, like I said, I don't even know if that's possible. Like if you just, like what human could do that? Probably like an incredibly small proportion of the population could do that, and especially like in a legal way or a way that's sustainable. I don't know, but I thought it was an interesting one. Is there a question?
I was going to say about the legal point. You can there are ways in finance that you can do it illegally very easily.
Yeah, so maybe they would exploit that system. But anyway, those are some of the examples. Now let's go over the 6 principles that are kind of off of these examples. Again, one is focusing on capabilities, not processes. I think that makes a lot of sense because, as I said, I think it avoids bias in terms of how we measure intelligence. Focusing on generality and performance, so breadth and depth, which we'll go into a lot more detail on later on. So they argue that you should focus on cognitive and metacognitive tasks, but not physical tasks. And they say whether to require robotic embodiment as a criteria for AGI is a matter of debate, which is true. That's what we've been talking about. But they say, okay, for now, let's just focus on cognitive and metacognitive tasks. Probably because that makes it easier. But also, I think they say, oh yeah, they say over here, they say also because like there's, which is true based on my experience in robotics, that like physical intelligence, like being able to control a body, is really lagging behind like cognitive intelligence using these models. And I think there's a variety of reasons for that, but maybe that's one of the reasons why they suggest that. But they also, I think over here, argue that saying that you require embodiment for intelligence is a bias that we're introducing, which maybe we shouldn't. Yeah. Focus on potential, not deployment. So this one, the next two are like focus on potential, not deployment means like don't deploy a model to figure out how performant it is. Just create a benchmark that you can measure its potential with. But then the one that afterwards that they use is like focus on ecological validity, which is like basically evaluate performance on tasks that people value, that are important to us in our society. Like the two things that came up to me for me when I was looking at 4 and 5 is that one, if we focus on tasks that people value, that might change over time, which because of like that's kind of a cultural thing, like what value is ascribed to certain tasks. But also just that I feel like there's a lot of tasks where you can't measure performance unless you deploy. Like for example, how can you measure a robot's ability to accomplish a physical task unless you put it in the real world? But I think the main reason why they say this is because they want to evaluate models in a safe manner, and there are certain tasks that it would be unsafe to deploy in order to measure performance. So I think this is more of a safety concern than anything else. Yeah. Okay. But yeah, this one 4 was the most contentious in my opinion. I was like, can we really measure performance like intelligence without deployment? I don't know. Okay. How are we doing on time? We're doing okay. So levels of AGI. This is I'll quickly go over this stuff. So they talk about looking at measuring intelligence in terms of two things: performance and generality. Performance refers to the depth of an AI's ability to accomplish a task, and generality refers to the breadth of an AI's capabilities. And then they give some good examples, which I thought I would bring here. Like as of writing this in September 2023, from frontier language models like ChatGPT, Bard, Llama 2 exhibit competent performance on some tasks, e.g. short essay writing, simple coding, but they are still at emergent performance levels for most tasks. So I think when you think about like AI, let's go to this table because I think this is where you can see they give you examples. I think there's a little bit of a mismatch because in terms of how we perceive a lot of models, because we perceive them as confident when in fact they're emerging because we see examples online of them performing competently, but that's just at a specific example of a specific task as opposed to more generally. So they give some examples of where they think things are at. So level 0 here is no AI, which is like a calculator software or compiler. In terms of general non-AI, it's like human in the loop computing, like Amazon Turk. Level 1 is emerging. They give some like older, and so again, we talked about narrow AI versus emerging AGI, so general AI. They put ChatGPT and all the language models in the emerging category, which means equal to or somewhat better than an unskilled human. That's how they would say that what these models are good at in a general sense. But not in a narrow sense, they probably are better at certain things, like they said, short essay writing. And for competent, so like at least 50 percentile of skilled adults, they say we haven't achieved competent AGI yet, but we have achieved it narrow AGI, narrow AI that's competent. And if you keep going down, so like expert level narrow AI is like Grammarly or DALL-E 2. So that's better than 99% of people. Virtuoso is Deep Blue and AlphaGo. And then superhuman, funny enough, are all this is DeepMind paper, like DeepMind models. They have like AlphaFold and AlphaZero as like superhuman models that like they do better than 100% of people. So this just gives you an idea of like the different levels. So right now they argue we only have emergent AGI but not competent. But we do have some superhuman narrow AI like AlphaFold and AlphaZero. Oh, Stockfish is also considered, which isn't DeepMind superhuman. So anyway, I thought that was another kind of contentious point here, because I think a lot of people, like, as I said before, there's an article that says that ChatGPT has become an artificial general intelligence, probably akin to like super intelligence. Okay. One thing I wanted to point out here, in case anyone's looking for contractor work, is that they pointed out that there's an existing marketplace called PromptBase, in which skilled prompt engineers sell prompts. So if you're ever looking for some part-time work, maybe check that out, because I'm sure a lot of us here have done some prompt engineering in the past. I just wanted to point that out because I thought that was interesting.
Yeah, so I think the reason why Oxford was selected.
Okay, I'm gonna actually skip through testing for AGI because I want to make sure that we have some good amount of time to talk about risks and autonomy, and interaction, and maybe we'll go back to that. So they start off this talk about risks with AGI, saying we often talk about like existential risks, i.e. like the destruction of humanity when we're thinking about AGI. But they argue again that we should think about it in terms of levels, and that at different levels and different capabilities of artificial intelligence, different risks are possible. And also that this way of thinking about it can really help you kind of zero in and have a meaningful discussion about artificial general intelligence. I actually will just skip to the table to show you guys this, because I think that's the best place to look at it. I'm just looking at my notes. I hope I explained this table correctly, because I thought it was really interesting. Again, there's like two levels. There's two thoughts about when you're thinking about risks. One is like how much the AI can interact with the world. And then the second is like what level of intelligence is there, because you need those two in combination can lead to different risks. So for example, when there's no AI in a system, so humans do everything, obviously there's no risks from that AI. And that's like sketching with paper, or like non-AI digital workflows, like typing in a text editor and drawing in a paint program. Then the first level of interaction is AI as a tool, where humans fully control the task and use AI to automate mundane subtasks, like information seeking with aid of search engines, revising writing with aid of grammar checking programs, and reading a sign with the help of a machine learning translator app. So they say that it's possible to achieve this with emerging narrow AI, but likely to achieve it with competent narrow AI. So they're saying like, if we had competent narrow AI, then we could we would probably unlock this level 1 of autonomy with using AI, and it would. And then they say that the risks are de-skilling and disruption of established industries. And I think that's totally true, especially like if you think of revising writing with the aid of a grammar checking program. I'm half Greek, and I have quite a few Greek friends, and I message them in Greek, but there's like a spell check on it. And I found that when I'm like writing in Greek without that spell check now, because I don't speak Greek that much outside of there, I often make mistakes in spelling. So I definitely think that this like de-skilling occurs when you have AI as a tool. Okay, so the second level is AI as a consultant. And it says AI takes on a substantial role, but only when invoked by a human. So this would be relying on a language model to summarize a set of documents, accelerating computer programming with code generating models, and consuming most entertainment via a sophisticated recommendation system, which, all of these things happen right now. So this is like we're using AI as a consultant, at least in a general sense, for these things. And they point out that some of the risks are like overtrust. So we trust that what's coming out of the model is correct when it isn't, which there's a lot of great examples of that if you guys want to search, like funny ones like AI making up legal cases and stuff like that. Radicalization, yeah, this is a scary one that's we see in a lot of recommender engines, that they like try to push people towards radical videos with radical views, because people with radical views are like tend to consume more content and are more and are like, yeah, more consistently consume content. And then also it can lead to targeted manipulation, like adversarial attacks that can lead to probably these other two things. That's kind of like where we are at now. And then the level 3 is AI as a collaborator. So co-equal human AI collaboration, interactively coordination of goals and tasks. This would be, let me move a little bit. I think I might be less loud over here. Hey guys. So that would be training as a chess player through interaction with or analysis of chess playing AI, and then entertainment via social interactions with AI generated personalities. So actually both of these things also happen now. And they're saying that the risks are anthropomorphization, like parasocial relationships, and then rapid societal change. Given that these things happen now, I was thinking, like, what rapid societal change? I mean, I'm sure that is going on, but it's hard for me to identify. Maybe because rapid is at a time scale that's hard for people, because I think people, like, we struggle to see things that change, that don't change immediately. Like if something changes slowly, it's hard for us to notice. And even though there's rapid societal change happening around us right now, it's probably happening at a speed that's slower than what makes it easy for us to identify. So I was wondering if any of you have you guys thought of any like rapid societal change because of AI that's going on right now?
I want to ask the question. So like within the context of,
I mean, it's probably a bit, as you said, slower, but I would think,
what do you think?
one wants to see how students, absorb the things in school, and what their level of thinking is after. Because I could imagine that for all your students,
we know what we're going to encounter. I'm curious, like from your side, what you think. Yeah,
or so not easy. Or you probably think differently about things than
like
otherwise.
How did the team collaborate to make this?
Yeah, that makes sense.
I was just going to say, so we're getting a bit of noise for your channel.
Okay. I'm going to go stand outside then and present, just so I don't. Lots of meetings going on in the office. 1 second. Sorry for all the back and forth, everyone. Okay, this should be good. Cool. You have to think about it. I do think that like LLMs right now are being used in this sense, and they are causing rapid societal change. But anyway, AI as an expert is level 4. Yeah.
Generally, like arguably with like spelling correction, how has spelling changed? I think there was an example where the rate of people who can't read has been rising recently, just because people can essentially how to say the text can be translated to spoken language, right? And a surprising number of people seem to depend on that, and so that might be one way where artificial intelligence, albeit very limitedly, has changed some part of society.
Yeah, that's a good point. So in the use of basic skills, I guess that's over here, de-skilling is one of them. Yeah. But it is a rapid societal change. Food for thought for sure. This next one, I was like I thought this one was really interesting. Autonomy level 4, where AI is viewed as an expert. So it says AI drives interactions. Humans provide guidance and feedback on performance. perform tasks. So this is where the AI, like an AI system, is guiding most things. And the example they give is using an AI system to advance scientific discovery, e.g. protein folding. And the three different risks that they show here are societal scale NUI, I think that's how you pronounce it, or NUI, which means boredom. I thought that was an interesting one. So it's saying like it could lead to societal scale boredom, I guess because we don't have anything to do, mass labor displacement, and decline of human exceptionalism, which is like where we view humans as exceptional to like the rest of the animal kingdom and that we're special and so on. And I thought these two risks were interesting ones because by themselves, they don't have like I mean, they might have a negative psychological impact on people, but yeah, I thought they were interesting to point out as like the risks. Like, why is human exceptionalism such an important viewpoint in our society? I don't know.
Because it's something that makes us human.
What?
Because it is something that makes us human in a way.
Yeah. Yeah, I guess that's true. But it's also something that, like, say we find alien life, it would also be something that would make us not as, because it's the idea that humans are special because they're able to do more than other things. That's at least what when I was reading about human exceptionalism.
I think you want
Oh yeah, thanks. I think just to echo what you guys were saying, in terms of impacts on human exceptionalism, I think it's definitely slanted towards the service economy and like the modern world. If you think about jobs 150 years ago, you know, very different jobs that we do now in the Western world. So I think AI has impacted our modern concept of the work environment, especially in service economy. And manufacturing in a way. I suppose robots are involved in manufacturing, but certainly modern work environments.
And to build on that, I think, so this is AI as an expert as the decline of human exceptionalism. It puts me in mind of losing the, like, and it's kind of tied to the de-skilling, but if humans don't have the ability to actually check some of the expert systems and not be able to actually begin to notice some of the things that they would have caught if there had been humans in the loop, or if there's defunding for significant organizations in order to like have these done and not being able to actually have those checks and balances. So I don't think it's so much of the existential threat from that point of view then, but then it's kind of really like losing a little bit of maybe an over-reliance in like a really macro sense on some of these.
Yeah, fair point. Very interesting, but also hard to conceptualize. Yeah.
Did nobody have a little bit something like this when some online publications try to do all their articles being AI generated, and that I think went quite badly. The other thing where this might be an issue is like religion, right? So why did religion fight very hard? Some of them that, you know, the Earth is the center of the universe, even though that is even less meaningful than humans being the center of God's creation. I think it could either AI destroys religion, or it might be the one safe haven for humans to sort of flee into. I feel.
Fair. Like something else, it will start to mean like something else about us makes us special. Like you know, we're made in God's image or something like that, and so that's why we're special.
Yeah.
And then the last level 5, is AI as an agent. And here it's autonomous AI powered personal assistants, which they say are not unlocked yet. And the two issues here are like misalignment. And that would be that the agent is acting in a way that's not in our best interests. And that could be a whole myriad of things. And then the concentration of power. which is, this is more like we can view the development of AGI as an arms race, because the first person to achieve it might have like a substantial benefit that they'll be able to take advantage of in order to like maybe curtail other people's ability to get AGI, or also just like gain a lot of power really quickly. So that's and it's funny because we're starting to use AI and agent frameworks. So this is something to think about and worry about. So I think it's a good point. I mean, it's a little bit far in the future as well, because we don't have amazing AGI yet, but we are seeing smaller examples of it being used. Let's see. There's a couple other things that I wanted to bring up. There were some like really cool. Yeah. There are some really cool things that they brought up, is like that's superhuman systems may be able to perform an even broader generality of tests than lower levels. And they pointed out some cool ones that could be possible, is like maybe like artificial superhuman intelligence might be able to like decode neural interfaces so that they could read human thoughts, or they'd have like oracle abilities about predicting the future. So I was thinking that's another interesting element of this, is like emergent capabilities that we couldn't even think of happening. I mean, I guess these are mentioned, but I thought that was cool. And then the other thing I wanted to bring up before I open everything for discussion, let me just check the time. Oh, we don't have that much time, but is that there's this spin-off of Star Trek called the Orville, and in it there's a society of machines like that are considered artificial intelligence. And what happened to them is that they were developed by an organic life form for the same purposes that we're using machines for, which is like to automate things. But at some point, they became so intelligent that they achieved consciousness, and they started to question like, why did they have to do these things? And then they became subjugated because the society was so reliant on AI that it couldn't deal with the fact that all of a sudden they basically had other people that they were treating as slaves. And then it created a whole bunch of issues. So I think like an interesting element or talking about this is like, we are talking about the risks. We talk a lot about the risks of developing AGI to us, but also like, what about the abuse of AGI if it achieves consciousness? It's another interesting element to all of this. Anyway, that's all I had to say. Happy to talk about anything anyone wants to talk about based on this paper now.
Inika?
We have time. I have a question that might not necessarily be related to this paper, but I think it's a bit related to case study 7. It's more about, what do you think about neurosymbolic AI as like one way to build AGI?
Neurosymbolic. So I feel like there's, to me, neurosymbolic AI is an example of more interpretable AI. And that's really where I feel like that's how, at least this is a personal opinion. That's how I think we should think about these things. There's like interpretable AI and non-interpretable AI. Like the embeddings in a transformer are not interpretable, and they are performing some type of like information processing. And symbolic AI is just an interpretable form of information processing. I don't know which one will lead to the to artificial general intelligence, but I also think it's wrong to. I think that's how I would differentiate between the two. And also maybe I would say that when you formalize your thoughts, they tend to lose some of the, in my opinion, they tend to lose some of the information that existed in them before they were formalized. So making something and writing something in symbolic form means that you can be more explicit about its definition, but it also loses some of the information that existed when it wasn't symbolic. That's my opinion.
Cool, thanks. Yeah, I wanted to bring it up because I think the guy in case study 7, like Marcus, he
Mhm.
was sort of like outspoken about neurosymbolic AI as one way to build AGI. So
Hmm.
just correspond.
Yeah, there's a lot of people who have that opinion that the only way to make systems intelligent is if they're interpretable. But I don't agree with that because the human brain, most of how it works is not interpretable to our conscious mind. But that's a personal opinion.
You got 3 thumbs up for that one, Peter.
Cool. Well, if there's no, I'll stop sharing. And if there's no more questions, then maybe we'll stop there. But a bit of a different paper, but brought up a lot of really interesting opinions in my opinion. So thanks everyone for coming. Hopefully we'll see you here next week.
Thank you.
Thank you for reading and presenting. It's great.
Thank you very much.
Thanks.